I would call myself a building engineer, so this is a building engineer's take on environmental master planning. I think environmental master planning is more than about integrating nature and creation of habitat. To provide comfort and facility in an environmentally responsible way, here for the teaching and learning of science at school, is also part of the master plan. This shares virtually all the same environmental drivers as the creation of this kind of learning environment. This is the view into the Sainsbury Laboratory in Cambridge, a research institution, part of the University of Cambridge. Exactly the same issues of effective ventilation, daylight, and use of shade and thermal mass. And I'm just going to pick up on that theme here. For me, again, we need to look at the spaces we're trying to create within the building when we're also looking at the site as a whole. So at the core of a school or a college or an institution are these learning spaces, and the plan needs to support them and respond to them. Adrian has mentioned acoustics. It's great, you've paved the way for me. Useful and controllable daylight and effective ventilation by whatever means. This diagram, which we frequently use, we think is a good way of trying to capture the balance that we need to strike between these qualities and in some cases how we might achieve them and where they overlap or indeed where they conflict. As I've said, both St Paul's School Science Building and the Sainsbury Laboratory have got all of the same agendas there. They're just operating at a slightly different level of learning or research. So an environmental master plan might discreetly integrate some of these elements or overtly express them, but it should always support the provision of the distinctive, inspiring learning environments that I've mentioned in the previous slide. It needs to respect its context, the built heritage, and it should enhance the experience of the students and staff, and beyond them, the community or the stakeholders, etc., who relate to that institution. And it should provide a framework to reduce consumption and consider the longer term rather than the short term and the capital cost only. And for St Paul's School, there were particular requirements here relating to carbon reduction, a 20% reduction against the baseline, but also the use of CHP and setting up of a district heating network, which are London-specific requirements. And I'll come back to St Paul's School in a minute. But virtually every project today will have a set of conditions with all or some of these attached to a planning approval. Another legislative driver presently, which many people seem to have some trepidation and fear about, is the Part L of the building regulations, which covers fuel and power, or effectively energy and emissions. And to support the nation's commitment to carbon reductions, it's also following a downward trajectory, and we await the final version of the 2013 Part L, which will push us to ever better performing buildings, at least in theory. Of course, we need to follow that through in practice, as Adrian has said. But I think in the future, we're going to see more on-site or near-site energy sources being used, because it's very difficult to pass Part L with a naturally ventilated building or a mechanically ventilated building without some reliance on renewable fuel sources. So my equation for energy and emissions here, which the building regulations only partly covers, is the sum of the energy used by equipment in the building, the heating and cooling in the building, and its lighting, less any contribution that renewables can make, and the zero might be your zero carbon aspiration, but most projects, that sum certainly doesn't add up to zero, and I think Adrian again mentioned rather bigger numbers in terms of kilograms per metre squared carbon. Building regulations might only really be concerned with these elements and less that, but if you're operating a building, or indeed if you're designing a school building, school complex, you should be considering this piece as well. And one of the failures, I think, in the public sector has been to decouple the design process for these facilities to these facilities, thereby missing an opportunity to produce a far better result overall. And as the buildings become better sealed and use less energy in the systems that the building regulations cover, the runaway electrical energy consumption, which Adrian mentioned, is going to be ever more important. And so clearly thinking about IT equipment, how you manage data are vital going forward. I think everyone will have seen a diagram like this before, maybe on your fridge, maybe about your building. There's a lot of confusion about what this means, and I just wanted to touch on this because, again, I think there's a degree of people being misled by the notion of performance here. EPCs, Energy Performance Certificates, are essentially a mechanism by which to prove your building, your school, your university against a benchmark building of comparable size. They mean nothing about the energy which you'll really consume in use in the building. And this is a very confusing notion because when the building is completed and occupied and the measurements made, the meters read, often a building which attained a very good EPC rating fails to get above the orange or even red in reality. And that's because, of course, total energy includes the computers, the plug-in loads, the photocopiers, the miscellaneous items which building regulations don't concern themselves with. So and I'm sure a few others in the room, hope that in the future our statutory legislation will look at all energy rather than just building energy, so that we focus on whole building performance rather than only statutory compliance. The kind of inverted Maslow diagram, which I've seen in many versions of, the 3 R's I've called it, as designers, we really should be, of course, through passive means and intelligent design, reducing demand as far as we can. We should be recycling or recovering energy when we can. We should use renewable, sustainable sources. And where we can't, we need to be responsible with our use of fossil-based energy systems. And of course, this will lead to lower life cycle costs. So it's a win-win if we achieve that. Planning and understanding the cost and returns on investment are an important part of developing an energy strategy or an environmental strategy. And this is an example of a piece of work for Queen Mary University where we tried to make projections of best case all the way through to worst case outcomes linked to time related to investment in their estate and their ambition to reduce carbon emissions. So it was introducing some reality to the practical process of realising a building. And again, a plan needs to think about practicality and realism rather than the absolute that I might have alluded to earlier. I've already mentioned St Paul's School in London. It is a 1960s class-built school. St Paul's School is a very successful independent sector school, and when they relocated from their original site to a rather nice riverside site in Hammersmith, they made a quite progressive decision to change the language of their school buildings to the then modern progressive use of system-built approach. They've looked after their buildings very well, but after 40, 50 years, they're nearing the end of their life, if not at the end of their life. And certainly some of the standards of acoustics and thermal performance that we would now expect are not met by the buildings. The school actually already had a CHP engine, which we've retained, but it's really there not as the primary source of heat on the site, because it's gas-fired, whereas our proposal is based on the use of biomass fuel in the boilers for heating water. And to try and integrate that kind of technology into an existing live school is also quite a puzzle. It's the kind of technical puzzle that we enjoy, but we have to think through a series of steps and interventions to get us to our end game, and we're partway through that process at the moment. We have a series of phases and sub-phases of intervention that we're working through here, and with the creation of some temporary and some permanent provisions. I'm pleased to say that we've recently completed science building, and that involves the first stages of this heating network. And this coming summer, we're about to start construction of a new drama centre, which will extend this sustainability network. And the third phase, which will happen in 2 years, will actually be to replace the main teaching buildings, and that will allow us to finally build a new energy centre. There will be space within it for that, to which we'll then couple these networks. This certainly will challenge your notion of what an institutional library should look like, whether from the outside or the inside. It's in an existing campus setting in Aberdeen, the oldest university in Scotland, and it's immensely popular. The building opened about a year ago, but it also has an interesting environmental story to tell. The library houses all of the original library, a much greater provision of IT and computing facility, and a major archive and conservation centre which attracts a collection from all over Scotland because they can offer the care to that collection which is not available elsewhere. So the building needs cooling really for dehumidification and control of moisture levels year round. There's an existing campus-wide CHP system which was put in by the university as part of their energy strategy, but one of its problems was that in summer there was no demand for the heat that it produced as a waste product, so that it couldn't be run very effectively. The library has a maximum demand for cooling in the summer. Normally this is provided with, or would be provided with, refrigeration machines, but we thought about, could we use the CHP engine? Is there a waste product here that we could use? Rather than asking for more electricity, can we use the heat that they would produce and they could use the electricity elsewhere on the site? So we worked with a particular supplier of desiccant materials. These are compounds which can remove moisture from air, but to use them you need to be able to regenerate their capacity with heat. And we could put the two things together, the waste heat from the CHP system and our need for dehumidification, into the ventilation system of the building. So it's a double win. The building itself uses less electricity and the campus is able to run its CHP engine through the summer months. We're currently monitoring this building with the university to try and understand those benefits over time. And the building has embedded within it quite a significant monitoring, a live monitoring capability. These are rather grubby bins of offal, or whatever the equivalent would be in a fish processing industry, which are turned into an oil or an emulsion, and you can burn them in a CHP engine. Quite a fuel to use, but it's a true waste product, and therefore it scores very well in terms of environmental responsibility. Working with both existing and new campus buildings, thinking carefully and understanding what your energy needs are, looking for some easy wins if you're trying to work with an existing estate, and realising that some technologies like lighting and computing are moving very quickly and might offer very large opportunities. Obviously the importance of feedback is vital, and Adrian has more than highlighted that. And it's important, I think, as somebody else has already said, to think about the remaining life of the buildings that you're working with. Spend your money wisely in terms of the longer term. The final point at the bottom there, it's something we've found on a number of projects where, particularly buildings of the 50s, 60s, 70s, where we've created new buildings that are effectively ventilated. They've surprised our clients because they've used rather more energy in heating in the winter months. But we believe that this is often that the older buildings only really worked because they leaked. They didn't have any means of ventilating in the winter. The air got in by accident. The classrooms were stuffy. Create a new building that resolves that particular issue, you actually need a little bit more energy. So the challenge then is to recover heat and minimise the amount of energy that you put in. It's incredibly important to understand occupancy profiles and the daily and the termly shift of loads and demands. Think about what energy you need and also where you might get it from, because sometimes site-wide strategies work Sometimes there may be synergies with nearby institutions and neighbours. The fish processing plant for University of Hertfordshire is quite a nice one, but it might be rather more that you have a relationship with a neighbouring institution which you could share some investment in the future. And I hope in urban areas we'll see rather more of that as well. Lighting technology I've already mentioned is moving very quickly. Thinking about how the systems work the whole year round, designers, particularly I have to say building services designers, become quite fixated with extremes and designing for the worst winter day or the hottest summer afternoon. The building really proves its worth if it can operate successfully throughout the year, and actually the very tips of the extremes should be given slightly less attention in that respect. People are resilient, people can dress appropriately when we reach those extremes. Again, picking up on Adrian's point, do engage with the users. They can actually help you realise the best outcomes. Some of Adrian's examples were very good ones about practical operational challenges, but if you can harness people and they can understand what can be gained, it's again a double win. You can improve the performance of the building and they can actually quite often enjoy a greater level of comfort. And maybe just to finish with emphasising Adrian's point, performance feedback is vital. We're currently trying to amass a much greater body of material about our own projects so we understand the design choices we make. But as Adrian has also hinted, it's actually quite hard to go back into projects, to go back to clients with whom you don't have a long-term connection. But of course, it's a great opportunity for them and us to learn from the projects that we realise. Thank you.